Hello, and welcome to Backer Breaks It Down. In this episode, we're going to continue talking about functions and function notation, and we're going to look at how do you evaluate a function and how do you solve a functional equation for a given variable using an equation table and graph. All right, so let's get started. Okay, evaluating functions is the process of finding the output value of a function that corresponds with a given input. Okay, so you know what to put into the function. The question is, what comes out? That's how you evaluate a function. So like in example 3 below, 3a, it says evaluate f of 0. And so the function f of t is equal to t squared minus 4. So if I want to evaluate f of 0, well, I know that 0 is the input. So I'm going to put it into the function for the variable t. So f of 0 is going to equal 0 squared minus 4. So I put it in and then I calculate it out. So 0 minus 4 is actually equal to negative 4, and that's the answer. Okay, solving functional equations. So when we solve a functional equation, this is the process of finding the input of a function that corresponds with a given output. So looking at example 3b, it says solve f of t is equal to 0. So you see the difference between the evaluate notation and the solve notation? Okay, it's all about like, what do you know? Do you know the input or do you know the output? This time we know the output. 0 is the output. So where does the output go? That's right, it goes on the outside of a function. So this is what it's going to look like. I'm going to have my function, because remember, f of t is the function t squared minus 4. So I'm going to have t squared minus 4 is equal to 0. Okay, so that's the equation that I'm solving. So isolate the variable, so t squared equals 4. To get t by itself, I do need to take the square root. So I'm actually going to get two solutions here, okay? So t is equal to, I think most obviously is positive 2, because 2 squared is 4. Another solution is negative 2, because negative 2 squared is also 4. So there are two possible solutions for this function equation. Okay, and that brings up an interesting point. So notice that when I evaluated the function, I only got at most one answer. Okay, I wasn't going to get more than one because then it wouldn't be a function. But when I solved the equation, like this particular equation had two solutions. So when you solve a function equation, it is possible to get more than one solution. It's also possible to not get a solution at all, okay? And so that's what we're going to see when we look at tables, all right? So whenever I evaluate a function, I should only get at most one answer. It's possible that I don't get an answer at all when I'm evaluating, but I definitely shouldn't get like more than one, okay? So if we take a look at number 4, it says f of negative 2. So I'm going to find the input value of negative 2 in the table, and I see that it corresponds to an output value of 10. So that right there would be the answer to number 4. When the input is negative 2, the output is 10. Number 5 says f of 1. So I'm going to find that input value of 1. And I can see that it has a corresponding output value of negative 8. So negative 8 is my solution here. So now let's take a look at 6 and 7. So I'm just going to erase my markings here because I'm going to like draw all over this thing, okay? So this says f of what is negative 10? So remember, negative 10 is an output value. So I'm going to find the output values in my table. And so here's negative 10, right? And what I see is that it corresponds to an input value of 2. So that means the answer here is simply 2, and it's just 2. This isn't happening anywhere else, okay? So let me erase this once again so we can take a look at number 7. It says f of what is 0. So I'm going to locate where my output values are 0. Do you see that? There are 3 places where I have this output value of 0. So that means there are 3 solutions here: negative 3, 0, and positive 3. All of those are solutions to this problem. because when I solve a functional equation, it's totally possible to get 0, 1, or more than one solution. Now let's take a look at how we would do this with a graph, okay? So 8 and 9, I am given the inputs, right? I know they're the inputs because they're inside the parentheses, right? So f of 2, I'm going to find the point on my graph that has an x of 2, right? So that would be the point right here. So when x is 2, I can see that the output of the function is 5, so that's my answer in number 8. I'll do the same thing with number 9, f of 0. I'm going to find that point on my graph that has an x coordinate of 0. It's right there. The y value is -3. And number 10, f of -5, I'm going to do the same. Look at this. Do you see that? Do you see that open circle there at -5? What does this mean when it comes to our answer? Well, because it's an open circle, that means, well, that there isn't a solution there, okay? So I'm going to write empty set like this. It also means that there's no solution because the function has no value when x is -5. That's what that open circle is saying. It's undefined, okay? So let me erase these markings so we can take a look at, like, how do you solve a functional equation using the graph, okay? So I'm going to get out a highlighter. F of x equals 0. So remember, 0 is an output value, okay? So it's a y value. So I have to find all the points on my graph that have a y value of 0. So this is what I do. I like to draw a horizontal line, okay? And that's representing f of x equals 0. And so do you see all the places that have an x value of 0? You've got one here. Well, they have a y value of 0. You've got one at -4. You've got another one here at 1 and another one here at 5. So there are 3 places on our graph that have an output value of 0. And so you have x is equal to -4, 1, and 5. So whenever I'm solving a functional equation looking at a graph, that's what I like to do. I like to use a highlighter or whatever I have handy, and I like to draw a horizontal line representing all possible outputs. And then I'm able to see exactly all the places that have that output value. In the case of number 12, f of x equals -4, there's only one such location, and that's happening here, right here, when x is equal to -1. Okay? So evaluate versus solve. When we evaluate a function, we're finding the output given the input. So I know what x is. What is y? And when I'm solving a function equation, I'm finding the input. I know what y is equal to, but what is x? And that is how Backer breaks it down.